All right, good job with finding the potential roots. So now let's go ahead and finish this process off. This is definitely one of the hardest things in Algebra 2, which is why you can probably understand we did not do this during remote learning. But the purpose behind all this, if I didn't say this in the last video, is that we know the quadratic formula, we know how to solve a linear equation, but when it gets into higher degree polynomials, we don't have a magic formula that we can just start plugging coefficients into and getting answers. What we need to do is we need to reduce that polynomial down to a smaller degree to where we do recognize the equation and we can figure out a process to solve it. Now, this goal is going to be to get it down to a quadratic, because then we can use our factoring techniques or the quadratic formula or completing the square if we'd like to. So finding all the roots using the rational root theorem. Now I'm saying all the roots because I'm not specifically saying that it's only going to be the rational roots. We could also have imaginary roots, which are derived from solving a quadratic using the quadratic formula, or if it's a binomial, just setting it equal to 0 and solving for it. So once we find some potential roots, we divide the original function by that root, or that factor. Now this is a little confusing as to why we did this, so I just gave a pretty simple explanation as to why. So for instance, if I had the number 24 and I want to know all the factors, and let's say you're talking to someone in the 3rd grade or the 4th grade, where this would be a little more applicable, you're trying to break it down to what times what times what is 24. So I know that 2 goes into 24, so what do? Well, you divide what you had by a factor or a root of that number. So 24 divided by 2 is 12. So I know that 12 went in evenly. There's no remainder. So I'm going to take that 2, I'm going to store that. And it's down there in my answer. And what I'm left with is 12. Well, what's a number that goes into 12? I know 3 goes into 12 evenly, so what's left? Well, 12 divided by 3 is 4. So I can say the factors of 24 are 4, 3, and 2. Or I could cut this down even more, saying that's 2 times 2, so 2, 2, 2, and 3. So that's just the general idea of what we're doing. We reduced it until we got to a number that we were comfortable with. We're now going to be doing that with this polynomial. So the potential would be a positive or a negative 8, a positive or a negative 4, a positive or negative 2, and then a positive or a negative 1. Now this is the pain in the butt part about this problem. There's no way to know which of these 8 roots is the root we want to use. So we got to guess and check. So guessing and checking, we're going to pick a root and we're going to divide. And if it goes in evenly, meaning there's no remainder, then we can move on. So I chose x equals 1. So I'll rewrite it by subtracting 1 from both sides to get it equal to 0. So that way I have a binomial that is going to be dividing this polynomial. And we go through the process. So hopefully you watched the video and you refreshed your memory, but I want this leading term to be the same as this leading term. I have a binomial, so I'm only going to look at the first 2 terms. And so x cubed, I want to turn this x into an x cubed, so I multiply by x squared. I multiply the x squared and negative 1 as well. Make sure you subtract both, so you have to change those signs. And then you bring down, bring down, bring down. I'm getting a remainder of 6. That means it's not a root. So now I'm going to try negative 1, or x plus 1. And then as you can see, down here at the bottom, my remainder is 0. So therefore, I know that I have 2 roots currently, x plus 1, and then my dividend, my quotient, x squared minus 6x plus 8. So now from here, I have a quadratic. I recognize that. I can either solve it by factoring or using the quadratic formula. In this case, it's factorable, so I factored it, and I set each of those roots equal to 0, and my roots are at negative 1, 4, and 2. So that means that this thing is going to be going up and down, and it's going to be crossing the x-axis at negative 1, 2, and 4. So what I've given you are 2 new problems. This one up here is a cubic polynomial, as is this one. This one is going to work out nice like the example I just showed you. You're going to want to find the possible roots. There's going to be at least one that fits in nicely, and then you're going to be left with a quadratic that will probably be factorable. This one is not so nice. You're going to do the same process, but the quadratic you're given will not be factorable, so you get to practice your solving using completing the square or the quadratic formula. All right, so try those out, and can't wait to see your work.